So lately I have a lot of students asking me about limiting reactants, how to figure it out. So I'm going to show you in this video, if you stick around, I'm going to show you two methods to figure out limiting reactants. But first I want to begin with a non-chemistry example just for you to conceptualize what is a limiting reactant in the first place. So let's say that you have 2 apples and 1 orange to make a fruit salad. That's the recipe. You need 2 apples and 1 orange. Well, let's say you have 4 apples and 3 oranges. Okay, so how many fruit salads could you make? Well, you could make 2, right? Because 2 times 2 is 4, so that means 4 apples, and 2 times 1 is 2, so you would need 4 apples and 2 oranges to make 2 fruit salads. But you would have only 1 orange left over. So let's say I tell you I need 3. Well, you would say I can't make 3 fruit salads because I only have 1 orange left and all my apples are gone. Okay, so that means that your apple is the limiting reactant, okay? And the orange would be the excess reactant. Why? Because you have 1 orange left over, but you don't have any more apples. So now that you understand limiting reactant, let's go into chemistry. So this is method 1. So it says, consider the reaction between 6 moles of carbon monoxide and 8 moles of H2 to produce methanol. Okay. So how many moles of H2 are necessary in order for all the CO to react? Well, again, if you're not sure about dimensional analysis and all of that, go check out that video and come back to this one. But pretty much, I want to see how, for all my CO to react, how many H2 would I need? So again, I have 6 moles of CO. And for every mole of CO, I have 2 moles of H2. Again, my units are going to cancel, and I'm going to have 12 moles of H2. I would need 12 moles of H2 to be able to use all my carbon monoxide or all of my CO. Okay, so some of you are like, okay, so what? Well, you have 8 moles of H2. Okay, in the problem it says you have 8 moles, but you would need 12 moles of H2 for all the CO to react. So what does that indicate? Again, you only have 8 moles of H2 and you need 12 moles for CO to react. So if you would need 12 moles, that means that your H2 is going to be your limiting because you only have 8 moles of H2. But let's keep going. How many moles of CO are necessary in order for all the H2 to react? So for your H2, again, you have 8 moles of H2, you have 2 moles of H2 for every CO, and you would need 4 moles of CO. That's fine because you have 6 moles of CO. So you would still have 2 moles of CO left over after doing that reaction. Okay? So again, H2 is going to be your limiting reactant and CO is going to be your excess reactant. If I said that too fast, I'm going to say it one more time. In the first one, it says how many moles of H2 are necessary in order for all the CO to react. Again, you're using all your CO. So you have 6 moles of CO, like it says in the problem, and you would need 12 moles of H2. But if you go back to the original question, it says you only have 8 moles of H2, but you would need 12 to react all your CO. So that means that your H2 is going to finish first because you only have 8, okay? Because you only have 8 and you would need 12, that means your H2 is going to finish first. If you look in the second part, it says that you have 8 moles of H2, and again, you would need 4 moles of CO. Okay, you would only need 4 moles of CO. But you have 6. If you go to the original question, you have 6 moles of CO, and you would only need to use 4 moles of CO for all the H2 to react. So if you still have CO left over, that's going to be excess. This is going to be our orange, like in the previous problem that we did together. Okay, so if this doesn't make sense, again, rewatch the video. It might take some time to understand. But now let's go to method 2. So this is our next problem. It says consider the reaction between 6 moles of CO and 8 moles of H2 to produce methanol. Again, it's the same problem. So again, you have 6 moles of CO, and again, you would need 1 mole of CO per every mole of methanol, and you would have 6 moles of methanol. Okay? Now, again, you would have 8 moles of H2. You use 2 moles of H2 for every methanol. And again, you're going to produce 4 moles of methanol. So what you're looking at is your yield. You're looking at how much product you would make. For your, if you use all your CO, you would produce 6 moles of methanol. If you use all your H2, you're only going to produce 4 moles of methanol. So what does this tell us? It doesn't matter if you can make 6. At the end of the day, you're going to use the one that makes the least. In other words, if you go back to the orange and apple thing, it doesn't matter if you have more oranges. If all your apples are used up, you're not going to make any more fruit salad. The same thing is happening here. You're only going to be able to do the least amount. So since you're only going to be able to produce 4 moles of methanol, that means that H2 is going to be your limiting reactant and CO is going to be your excess reactant. How do I know that? Again, I'm taking my reactant and I'm seeing how much of that reactant would produce product, okay? So since I know that I'm only going to produce 6 moles with 6 moles of CO and 4 moles with 8 moles of H2, then I know that 4 moles is less, and that is going to be how much product I'm going to be making. I hope you enjoyed this video. I hope you enjoyed the methods. Again, that is how you can identify. You don't have to do both methods unless your professor asks you to, but choose which one makes more sense to you conceptually. Again, if you don't completely understand it, please let me know in the comments. And thanks again for watching.